Hello, math fans! Welcome to Math Olympiad Academy. Today, we have a very interesting challenge. Can you find the exact value of the integral I, which is the integral from minus infinity to plus infinity of e to the power of minus x squared with respect to x? This integral appears often in probability, physics, and advanced calculus. Let's solve it step by step. Before to find the solution, let us label the integral as I. We can also write it using another variable, y, so I is also equals to the integral from minus infinity to plus infinity of e to the power of minus y squared with respect to y. Now, consider I squared, which means multiplying I by itself. This gives us a double integral over the xy plane, the integral from minus infinity to plus infinity of the integral from minus infinity to plus infinity of e to the power of minus x squared minus y squared dx dy. Writing it this way prepares us to simplify the problem using polar coordinates r and theta. Evaluating this integral in Cartesian coordinates x and y is difficult. To make it easier, we switch to polar coordinates. We set x equals r cosine theta and y equals r sine theta. Then x squared plus y squared equals r squared, and the area element dx dy becomes r dr d theta. Substituting these into the integral gives I squared equals the integral from 0 to 2 pi of the integral from 0 to infinity of e to the power of minus r squared r dr d theta. Next, notice that the function e to the power of minus x squared minus y squared is even in both x and y. This means its graph is symmetric about both axes. Because of this symmetry, we can focus on the first quadrant, where x and y are positive, and multiply the integral by 4. This simplifies our expression to I squared equals 4 times the integral from 0 to pi over 2 of the integral from 0 to infinity of e to the power of minus r squared r dr d theta. To make the radial integral more manageable, we temporarily replace infinity with a finite positive value denoted a. Then I squared equals 4 times the integral from 0 to pi over 2 of d theta, multiplied by the integral from 0 to a of re to the power of minus r squared dr. This allows us to solve the integral over r first, and then take the limit as it approaches infinity. The r integral can be solved using substitution. So, let u equal minus r squared, then du equals minus 2r dr, which gives r dr equals minus 1/2 du. Substituting into the integral, we get the integral from 0 to a of re to the power of minus r squared dr equals minus 1/2 times the integral from 0 to minus a squared of e to the u du. Evaluating the limits, we find it equals 1/2 times 1 minus e to the power of minus a squared. Now, we take the limit as approaches infinity. The exponential term goes to 0, so the r integral evaluates to 1/2. Next, we multiply this by the angular integral, which is pi over 2, and by the symmetry factor 4. Doing the calculations, we have I squared equals 4 times pi over 2 times 1/2, which simplifies to pi. Finally, taking the square root, we find that I equals the square root of pi. And that is the exact value of the Gaussian integral. This integral is not only elegant, but also very useful in probability theory, physics, and advanced mathematics. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!